Welcome to this special episode of the Geotechnical Engineering Podcast. In today's episode, as a part of celebrating Women's History Month, we'll be exploring the importance of thinking outside the box in geotechnical engineering, with a focus on the contributions of women in the field. Our guest for today is Shawna Munn, P.E., who is a senior engineer at Isherwood Geostructural Engineers, and she's a trailblazing woman in geotechnical engineering. We'll be sharing her insights and her approach to challenging problems and how she finds creative solutions for the task at hand. We'll also be discussing the significance of unconventional solutions, strategies for thinking creatively, and how geotechnical engineers, particularly women, can leverage emerging technologies to make a significant impact in the field. I'm your host, Jared Green, and I'm excited to be bringing you another episode of the Geotechnical Engineering Podcast. But before we get started, here's a quick word from our sponsor for today's episode, that being PPI.
Before we dive in, we'd like to recognize our sponsor for this episode, PPI, a leader in engineering exam prep for the FE and PE exams. PPI provides expert prep courses and study resources designed to help you pass the FE and PE exams the first time. PPI's live online courses include hours of lectures, problem-solving demonstrations, exam strategy sessions, office hours, and a passing guarantee. Check out PPI today at ppi2pass.com to see all the options available for FE and PE exam prep. Now let's dive into today's episode.
All right, welcome to the show, Shawna. How are you?
Great. How are you, Jared?
I'm doing well. Really, I have been looking forward to this conversation, so I'm glad you could carve out a little time for us to talk with us.
Absolutely.
All right, great. Well, it'd be great if you could tell our listeners a little bit more about yourself and what is it that you do on a daily basis?
Sure. I'm a senior engineer at Isherwood Geostructural Engineering, which is a little consulting firm outside of Toronto, Ontario, so about 60 employees. I'm a senior engineer, and my current role is, I'll call it mostly firefighter. So I go around and put out fires that people have or solve problems, or work on problems or projects that don't really have a standard solution. So problem solving and creative thinking and trying to figure out how to actually get things done.
Awesome. Love it. Oftentimes when people ask me, what civil engineers do, I say that they're problem solvers. And if you think about geotechs, it's like we have to do problem solving with an engineering material that's soil and rock and groundwater. So pretty challenging stuff. Now, you talk about thinking outside the box. Now, when it comes to tackling these challenging projects in geotech, especially if it's one that, that doesn't have like a typical solution, can you walk us through your approach for how you tackle things like that, Shawna?
Sure. I mean, like Ralph Peck said, subsurface engineering is an art. And so I approach things that way and with that mentality. So if you approach something like you're finding the solution or there's only one solution, then you can be a little bit closed-minded and your box gets a little bit too small too quickly. Yep. So the way that I approach challenging problems to make it a little bit less daunting and a little bit simpler is to find three sides to the box. Okay. So you got to find a foundation. We're in the foundation industry. You got to find a foundation to work from. So you find, like when you're putting a puzzle together, right? Like you're looking for the pieces that make sense that you can put together. So it doesn't matter if you're a senior engineer or new on the job, you know something about the project that you're looking at. You know maybe where it is. You might have some information from some jobs that are around it. You can look at if I speak from an excavation shoring perspective, you can look at what you're protecting. Mm-hmm. So you start to put together those parameters. So if you try and solve a problem without defining parts of the problem, then you don't really have a foundation to work from. Yeah. So once you have that, then that kind of launches like the three sides to your box that launch the creativity. So then you can look at, what options can exist. And if you run into a roadblock, well, then how can you actually remove that roadblock? So, I mean, I've run into examples on projects where you might say, well, the deflection of this is too high. And then instead of being like, well, it doesn't work, you go, how can I get the deflection of it down? What can I do? Yeah. So if you approach things that way and you just piecemeal kind of build the puzzle, you might see that it looks entirely different than what you actually thought it might be if you try and just slap a solution on it right at the beginning.
Yeah. Now, that makes a lot of sense. If you're, I guess there's a saying that said, "Don't ask a barber if you need a haircut," right? Because you're gonna say yes. So it's like if you come into a project with a bias, like, oh, we're gonna have deep foundations, then you're gonna have deep foundations. So I like this thought of actually defining it, right? You're defining it, starting with the edges of the puzzle, and then working towards putting it all together.
Right, because maybe microfile foundations were the right answer for the deep foundations project. Like when you went in, right? You don't know. You got to like actually work your way into it and have an open mind. And so I find approaching it like art helps you do that rather than science or engineering. And that's kind of some advice I've given to my colleagues is they get a little bit uptight because they want to like do some calculations or have an answer right away. Yeah. And I'm like, okay, but if you approached it like you were painting a picture, you wouldn't feel that way, right? You'd try and be open and loose and like flowy, and like you'd have to have an open mind, right? You'd step back from the problem a little bit. And so if you approach it that way, you end up with a different way of thinking. You're using a different part of your brain, which helps you find different solutions.
Yeah, no, I agree. And I think that that really should be exciting to some of the younger listeners, because the reality is that sometimes if we're looking at something for too long, we're kind of thinking it has to be this way. If somebody has a totally different idea because they haven't looked at it very long, thinking outside the box. So when we think about when we're in school, a lot of times we have a problem, we get a friction angle, we get cohesion, we get C sub C, we get these parameters, and then we solve the problem, right? But a lot of times our real world situations, there are unconventional solutions that are needed. Can you give us some examples of, what that looks like, what it feels like, what those experiences are like?
Yeah, I mean, as you were talking about being in school and things, I was thinking what people miss understanding is the creative aspect of what we do, right? And so I think some people might not want to go into engineering because they think that, it's not creative enough for them. But I couldn't be in the industry that I'm in or the position that I'm in if I wasn't able to be creative at my job. Yeah. So like I need both of those facets to like actually engage me. So I think in school, you're right. So often it's rote learning, or you have to follow the processes and the procedures to get the right answer. And that's important because you need to know how to do that. But I think the perspective of how you can apply that, or what that can turn into once you get the tools in your toolbox, or the paint and the paintbrushes in your painting kit, it looks different in the application. So, I mean, the most fun that I have on projects, and that I will use that word, like I have fun doing what I do, is those projects where, they're so complicated that you have to like put them up on the wall, like a Beautiful Mind style. And like sit in a room and like you're staring at them, and all the numbers that fly around, like you're just looking at it going like, how is this puzzle piece going to go together? And then you find the one thing, right? And it's like pulling a thread. It's like pulling and so that one thing leads to the next thing, leads to the next thing. And, it's a little bit of detective work, but seeing that come together in a way that looked almost impossible from the beginning is so rewarding and so fun, right? Like it's like there's so few opportunities that we get to actually, I guess, in the analysis. We don't get to do creative analysis often, but in the way that you put things together, in that's what you can do. So I mean, there's projects that I've worked on where, all the constraints just seem like, what can you do? Like, what can fit here? And so like, give an example is the one in Toronto. So that one was Canada's first super tall building. And on one wall, we just couldn't get any tiebacks. We couldn't get any anchors outside of the site. And the way the site geometry was if you started actually it was really deep. So if you put rakers, like that wouldn't really work. Or if you put cross-site struts, it would totally cut off access from the site and make it almost non-constructible. So what we ended up having to do is there was this one tiny strip, one tiny laneway between properties that we could use. And so we created, and this was our principal engineer Natter's idea, but what we created was a super pile and a super corner, we called it. And it had 13 rows of tiebacks.
Okay.
And I think just as many rows of whalers going across it, but it supported half of the entire east wall, like just on one pile.
Okay.
And like you look at the section, and even Brian Isherwood, who founded our company, I remember when he came over and looked at the drawing, he was like, I've never seen anything like that before. Because it's just the section looked crazy, because you just had like 13 tiebacks just like splayed out down this one double super pile.
Yeah.
And it worked. And I mean, you need to think about like, that's the good news. It worked.
That's the good news. It worked.
So like, you have to think about how to validate that it works. I mean, that's the whole other side, the other fun side of using the observational method, right? You come up with an idea, you figure out how you can monitor it. So in that case, we put a shape accelerate on the pile. And so we had real-time monitoring the entire time to figure out if our idea was all it was cracked up to be.
Yeah.
And you validate and you modify if you have to. Yeah. And so finding out that whole dance to how the design goes from the beginning to the end, like that's a lot of fun.
That's awesome. I love it. I love it. So this super pile, is this like in the end, like a traffic pole? Not a traffic pole, but like, like a pole with like things just coming out of it, the tiebacks coming out of it, or tying into it?
So it was like an excavation support system. So it was a soldier pile, like in the ground, like a drilled shaft with two double, I think we ended up on 690 piles. Okay. Because we just had that much load going through them that we created a double pile. Yeah. And then you couldn't see the anchors just on the face of the excavation. They were under the ground in that laneway. Got it. Yeah, if you look on the drawings, I mean, that's always the thing. And what we do, it's not really appreciated. It's always hidden under the ground.
You don't get to see it.
No. And even when it's done, it's not the permanent structure often. So it's kind of a hidden from most people, but yeah.
Awesome.
We know it's there.
We know it's there. Took care of the loads. All right, that's great. Well, that's definitely unconventional. When the founder of the firm walks by and says, "We've never seen that before," that's a big deal.
Yeah, you kind of go like, "Oh,
it's like, no, wait a minute."
I better look at this like 1 or 100 more times.
Exactly. So you kind of hinted at this a little bit when, the corners of a puzzle or the edges of the puzzle, or, just trying to define this box. But what are some other strategies that you've been using to find the foundation for thinking outside the box and for coming up with a creative solution and really focusing on what it means for the geotech?
So we utilize this method, and we have sessions occasionally after work we've had for a long time called Socratic dialogues. And so it's the process of asking questions. Okay. And so that's the way you find those puzzle pieces, right? So whether you're a geotechnical engineer or not, like that's the way you find answers to questions that can start to make that picture look a little bit more clear, right? Like it comes into more focus every time. So it's what do we have to protect? Like, what are the risks? What are the obstructions to this design, right? Like what's in the way? Like what would stop us? Like if you're doing a design beside existing transit infrastructure, right? How do we manage the risk of that? What are the constraints that come from that, organizing body? And you start to get the picture to come into focus. And so, like in soil parameters, in the geotechnique, what information do we have? Like what exists? Is it a job with only, one borehole? Is it a job where you got a geotechnical baseline report and you got lots of data? Is it a job where you've done every job site around and you kind of almost have the full picture? And all those things put you on a different spectrum of how you have to approach the design. Yeah. And so finding those things and not rushing to an answer is like allows you to be more creative, right? Because you have all those things like kind of all around you as, like I said, the foundation for actually looking at the problem. Because now at your fingertips, you have all the information that you need to validate if your ideas are a good idea or a bad idea, right? Because then you go into brainstorming mode, right? Where nothing is a good idea or a bad idea, but you kind of like throw something and you see if it sticks. And if it
Yeah.
sticks, it's the way you figure out if it sticks is if you check it against the criteria that you just laid out.
Yeah. That's awesome. Now, those Socratic seminars, is that something that everybody was invited to? And when you're all there, do you go through like a specific project, or is it like more aspects of multiple projects and like theme based for a session? Like, how does that
So it
work?
would be like, can you come up with 100 questions you would ask on like you would ask when you started a job. So not necessarily like for any job, but it's like the same thing in university, training you how to think, right?
Yeah.
Like
Yep.
you go to engineering school, and that's what I tell people when people ask me, should my son or daughter go to engineering school? And I said, well, what I think engineering, like in university, taught me is to think, like how to think.
Correct.
Like an engineer. So the same way with the Socratic dialogues, when you train yourself to ask questions, it's training yourself to think a certain way.
Love it.
So it's just an extension.
Love it. I think that yes, the Socratic seminar, I think that reinforces the notion of always remaining curious, right? It's
exactly.
like if we're not curious, then we're not going to be problem solvers. We're not going to have good solutions. So
exactly.
I really like that. Really like that. So we talked about, thinking outside the box. Can you share an example of a project you worked on where perhaps a conventional solution didn't exist and you had to approach it using an unconventional way?
Sure. So let me think of which one I would share with you. So another one would be for the Eglinton Crosstown line, Cedar Rail Station in particular. That was one where we actually just got the runner-up award for the Outstanding Project Award.
Congrats.
And thank you. That was very cool. But one aspect of it in particular took a lot of thinking outside the box. And that was where we had to actually support the excavation underneath the existing subway line. And so the first step of that was designed by the structural engineers and the mining engineers to make these mining galleries and put the underpinning beams. But then we were left with these, very small, I think it would have been less than 8 feet in height underneath the existing subway box. Very low headroom, not even enough to get a small tieback rig in because the girder beams were in the way as well.
Got it. So you're coming down even lower. Yeah.
Exactly. So, and it was a 12-meter span. So that would be, let me flex my ambidextrous, 40 feet across.
Okay.
So clear span. So you're like, what do we do? How do we support this? I don't really want to put a cross site strut across or multiple of them because again, you're going to cut off access to, like, it's going to be so hard to even get those underneath this little spot. So what do? Can't really fit in so you start to think about, you're like, okay, well, conventional solutions, let's think about them.
Yeah.
Well, getting a strut in there is going to be near impossible. Okay, what's next? Can we look at, is there a small enough tieback rig that can actually fit in with that geometry, or a soil nail rig even, like something? Can we get it in there? No, not enough room, even with the smallest ones available. All right, then what do we do? Because you have very strict, like I said, deflection tolerances. So we had to keep the deflection to L over 1,000. So that would be 12 millimeters or half an inch maximum for that 40-foot span. And so we're like, what do we do? So first we're like, well, maybe we could put a whaler to span across. And so you try and figure out, how can I fit in, a big beam in there? And even some of the biggest, heaviest beams we were looking at didn't meet the deflection criteria for that span. We're like, okay, well, now what do? We look at a double beam. Okay, no, that doesn't work. That didn't meet the criteria. Okay. Well, what in the heck are we supposed to do next? And so we came up with this idea to preload them like a bow and arrow. So we had one on one side of the box and one on the other side of the box, right? Each side of the excavation. And what we did was we put a series of tie rods across them because you didn't really want to, you want it to mimic the deflected shape when you preload it, right? So you don't want to put one tie rod, you want to put several. Yep. So we had a series of them. And what we did was we preloaded it to basically where we'd get half the deflected shape under the final design load.
Okay.
We preload them against each other. So it's kind of like a bow and arrow. We pull that load out. Yeah. And then we filled it we had reinforced rebar and basically filled it with concrete. When the concrete reached a minimum strength for the compressive load, we let the load back off. So we preloaded the whaler like a bow and arrow. And to my best of my knowledge, that hasn't existed. But it worked. It really worked.
Yeah, that's awesome.
But it's like, how can we, like, instead of getting stuck, just view it as hurdles, right? Like, how can I get over, under, around this problem? And look at the problem from a different angle instead of like, well, this is not a solvable problem. Like, I guess you're not building your subway today. You like look at it as like, well, how could we remove the deflection? Is this a crazy idea? Don't be scared of crazy ideas, right? Like just vet them. And you might find that one or two of your crazy ideas actually work. Like, I'm sure that 8 out of 10 of my crazy ideas don't work, but it doesn't scare me because then you find the one or two and like that's so fun that one actually worked.
Yeah, and it's so rewarding when you get to that point because it's like it's not impossible. We just have to figure it out, right? And when you get there, it's like we got there.
Exactly.
All right, cool. So when I think about geotechnical engineers, it dates back to the days of antiquity, right? But the sophistication of what we do now makes it still feel like it's emerging. And emerging technologies have changed the way that we approach, especially these very complex problems. You start getting the soil structure interaction and seismic activity. There's like a lot of things that we're able to do now that would have been a lot harder before. But how would you say geotechnical engineers are able to leverage these technologies when thinking outside the box and tackling challenging projects in new ways? What are your thoughts there?
Well, I mean, when I think about it in terms of like emerging technologies, you could look at the modeling aspect or you could look at the instrumentation aspect, right? But both have power when it comes to supporting and facilitating those things, especially when you're creating something that hasn't existed, because then you need a pretty extreme amount of validation throughout the process to make sure that it actually is doing what you thought it was doing. So, I mean, on the modeling side, like the finite element analysis modeling and things like this, it gives engineers a tool, like a powerful tool to, again, validate and check their assumptions, right? And so we never use FEA as a design tool. We use it as a validation tool because you should almost know the answer before it comes out. And so it's one of those things like garbage in, garbage out. Like that's never the spot to start. That's like the last step where you're like, oh, I want to know a little bit more exactly about the deflection because there's a deflection sensitive structure around or something like that, but never to get the actual size of the pile. Maybe to like fine tune that last, 20% or 10%, but never to get from scratch. And then on the instrumentation side, we have a sister company who does instrumentation. That's so powerful. I mean, on both jobs that I just talked about, instrumentation was key in validating it, right? So having the in-place inclinometer, like the shape accelerator at the super pile at the one was key to seeing if that actually worked. And not just having like regular even inclinometer data, but having like that real time, how is this moving at each one of the steps? And the same thing, having instrumentation with, really effective and accurate survey monitoring to see what the deflected shape was, because that's how we checked it. We preloaded it, but we were surveying what the deflected shape was, again, to validate, are your assumptions correct? So without technology, that we are stuck kind of in the stone ages of geotechnical design. Technology is what takes us to that next level and be able to think outside the box.
Yeah. Love it. Love it. Love it. It gives us the ability to, think outside the box, do things in a way that's more sophisticated and control things. We're able to see, is it working or not?
Yeah, right. Leveraging the observational method, using these new technologies gives us a power beyond what existed before.
Excellent. Excellent. Wow. So we're going to be, we're shooting this now in March. And so there's we're talking a lot about women's history and, so I think about women in geotechnical engineering. So how can women in geotechnical engineering use past successes and failures as a foundation for thinking outside the box and finding innovative solutions for future projects? What are your thoughts there, Shawna?
Well, I think it's important as women in engineering, which we're not, we're kind of a smaller demographic inside of the engineering bubble. And then you think about construction and geotechnical engineering, and that's sometimes even smaller than some other kinds of engineering. And so it's important to recognize the unique strengths that we can bring to problem solving, because women think differently. You know, our brains are created a little bit differently. And so that's not a weakness, right? Sometimes we feel like we need to fit inside others' boxes and be the same and like fit in as a woman in a man's world. But you don't. Just bring what makes you unique, because your different perspective, your different experiences, and your different perspectives of everything really add to the way that you think about a problem, which will be different than somebody else. And every new viewpoint or perspective on a problem adds value. And so, I mean, specifically with failures, I don't think there's probably been a geotechnical engineer that's worked in industry that hasn't had something not go right. So it's how you approach that and how you learn. So specifically at Isherwood, we have this, one of our main things is mistakes are viewed as learning opportunities. And so it's one of those things, is what you take out of it. Certainly you don't want big failures where there's, you know, loss of life or loss of property or things like that. Like, no, but those little things that people could view as setbacks, don't view it as a setback. Look at, what did I learn from this? Because I guarantee you wouldn't learn as much if everything you did was wonderful and successful. Like, that means you're not really pushing yourself. You're not really challenging yourself. You're not really growing, because in those challenging times is actually where growth comes from. So if you can change your mindset to focus on, well, you know, why didn't this go great? And what could I do differently next time? Or like, how could I approach it differently next time? Or, you know, what's my takeaway? Then you grow, right?
Yeah, that makes a lot of sense. And, you know, you said something that made me think, it's so important when somebody shows up to work or shows up on a project or shows up as part of our team. We want to make sure that they can bring their full self to work, right? We want to bring their full self, because their perspective, if a team is good, their perspective can be totally different from mine. And that's how we gain, right? Like, if everybody thinks exactly the same, it's like, why do we need 10 people in this room, right?
Yeah, exactly. If you're just going to think like me, I don't need you here.
I don't need you.
Now you're just mimicking me, you know?
Exactly.
Like, so if we all can show up and feel safe being like our authentic selves and bring that, you know, I mean, level of craziness, I guess, like we all have our little bits of the thing that make us us, then that ultimately benefits the team.
Yeah, I agree. Well, before we take our break, final piece of advice that you want to give to those that are listening, women that are listening in. It could be geotechs, it could be engineers. What do you have to say to them before we take our break?
Yeah, I think I would say that, again, probably to reiterate some of the things that we talked about, is don't be scared to find your place and find out what that looks like for you. And that doesn't need to be the same as anybody else's. So the way that I've approached my career is probably atypical, but it's similar. I find I like only 3 sides to my box. I do not want to live in a box inside what I do. I would like definition. I don't really want a full job description. I want like 3 sides to my box. And then I just want to, you know, solve problems. And ultimately that's provided value in the setting that I work in. So don't be scared to find out what works for you and to set boundaries when it doesn't. Because that's the other thing I think sometimes we're scared to do as women, is say no and set boundaries. And we think that'll set us back. But I think, again, in my career, knowing when to set those and make things, again, like reset what's healthy for me in terms of like what sets me up to be the most successful, which ultimately sets the company up to be the most successful, is what's allowed me to grow in my career. So if you don't do that, sometimes you get stuck and sometimes you get demotivated. And so there's nothing, like, I would like empower yourself to find those things.
Excellent. That's a great note to pause on. So we're going to come back in just a minute close this one out with Shawna and our career factor safety end segment. All right, welcome back. It's time for our career factor safety end segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor of safety into your design. But what about incorporating a factor of safety into your career? Today, of course, we're speaking with Shawna Munn of Isherwood Geostructural Engineers. Now, Shawna, you've had already a successful career, which I know you're still in your career, but you've had a successful career so far. Now, when you look back on your career, what's something that you implemented in your career to give yourself a factor of safety in your career?
So I would kind of say it's two-pronged. One, having mentors in your career. I've had a series of mentors, and I've been very lucky to have a series of mentors throughout my career that have taught me different things, where I literally remember sitting on the floor outside someone's desk telling, how the heck do you design a whaler? And sitting there and like, how do you design this one? And like finding those people that will make time for you and walk you through basically how to approach things from different angles, whether that's risk management or actually technical design or how to approach challenging clients. Find those people that you can actually like immerse yourself a little bit in and learn by osmosis from. I think that's one of the biggest benefits in my career, is the people that I've been surrounded by. And I think that's extremely important, especially early in your career. Like I would even take a less sexy job in order to just be around people that you can like really absorb things from. And the second part of that is remembering to be humble, because you're not going to be right all the time. And I know that's hard for engineers to hear, because we really like being right. We really like finding the right answer. It's kind of like built into us. But maintaining that level of humility helps you grow in your career, because then you have, again, a greater perspective, not only on the world around you, but yourself. And so that allows you to find the areas in which you can actually grow.
Wow. Shawna, I really enjoyed this conversation. Thank you so much for coming on and for sharing all the great insights with us. You shared great information. I know it's going to be helpful for our listeners and those watching. If somebody's watching, they want to know how they can get in contact with you. How can they find you? You have an email you want to share, or are you on social media?
Sure. I'm on LinkedIn. I don't have very many other forms of social media. But you can also reach me at Shawna@isherwood.to. So SHAWNA@isherwood.to. Excellent.
Well, thank you so much. This was a lot of fun. Take it easy.
Thanks, Jared.
All right. Thanks. Bye now. I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, that being episode 72, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, we wish you the very best in all of your geotechnical engineering endeavors. Peace.